So the last example, or the last method I'd like to cover, is the use of trigonometric identities. So one example is if we have the integral of, well, we can make it a definite integral if we want, but we have an integral of sine squared x dx, and we can make that into a simple form if we remembered, if we looked at our calculus book again and looked at our trigonometric identities and saw that 2 times sine squared x is equal to 1 minus cosine 2x. And by doing that substitution, we get the integral from 0 to 2 pi of 1/2 times 1 minus cosine 2x dx. And that is equal to 1/2 times x minus 1/2 sine 2x plus our constant. And we can go ahead and multiply the 1/2s out, so we get it x over 2 minus sine 2x over 4 plus our constant. Okay, so that was an example of doing a trigonometric substitution to make the integrand something simpler to solve. Trig substitutions are also good for integrands of the following forms. Square root of ax squared minus x squared, square root of a squared plus x squared, and the square root of x squared minus a squared. So for example, if we have the first form in our integrand, a squared minus x squared to the 1/2 power, we could make the substitution that x is equal to a sine theta, because that would give the square root of a squared minus a squared sine squared theta. If we were to factor out the a, we would get a, so the square root of a squared is just a, and we get 1 minus sine squared theta. And you might remember that sine squared theta plus cosine squared theta is equal to 1, and therefore 1 minus sine squared theta is equal to cosine theta. And so then this integrand becomes a times the square root of cosine squared theta, and that's just equal to a cosine theta. So that's a slightly different, simpler form to a more simple form that we can solve more readily. So let's consider the other form, the second form, which is the square root of a squared plus x squared. And we can make the substitution that x is equal to a tangent theta, in which case we get a times the square root of 1 plus tangent squared theta. And 1 plus tangent squared theta is equal to secant squared theta. So our integral becomes a times the square root of secant squared theta, which is equal to a secant theta. And that has a simple integral, which you could, if you remember, great, or you could look it up in an integral table. So that was our second form in our integral. And the last form was x squared minus a squared. And we could substitute, we're going to end up using the same trig identity. If we substitute x equal to a secant theta, the integrand becomes a times secant squared theta minus 1. And secant squared theta, again, well, is equal to, by this same trig identity, secant squared theta minus 1 is equal to tangent squared theta, and therefore our integral becomes a tangent theta. Okay, so that was some examples of how to apply trigonometric identities to solving integrals of more complicated forms. And so we've covered 3 methods of integrations: U substitution, integration by parts, and trig substitutions, all with the goal of producing integrals that are easier to solve than the initial. So that will conclude this video, on the second video on integrals.